define the residue. What is the residue? And here we define the residue for the isolated singular point. So here what is the residue basically? Residue of isolated singular point. 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 So if, what is the definition? If fz have isolated singular point, isolated singular point, isolated singular point at z equals z0, then there exists a small region, then there exists z minus z0 less than r. If we write r greater than 0 means there exists a dilated neighborhood. There exists z minus z0 greater than 0 is less than r for if fz have isolated singular point at z equals z0, then there exists a region z minus z0 is greater than 0 less than r for which fz have Lorentz series such that Lorentz is about z equals 0. If we write about z equals z0, about z equals z0, about z equals z0, such that fz equal what? Fz equal summation n equals 0 to infinite an z minus z0 to power n plus summation n equal 1 to infinite bn upon z minus z0 to power n. As we know that this one is a what? This one is a Taylor part. This one is known as a what? Analytic part. Analytic part as well as Taylor part. Taylor part, and this one is called what? Principal part. Principal parts. So if fz have a isolated singular points, then we able to expand fz about z equals z0, then fz equal summation n equals 0 to infinite an z minus z0 to power n plus n equal 1 to infinite bn divided by z minus z0 to power n, where an is a what? An is a, where bn is a what? bn is a 1 upon 2 pi I integrate over c f of w upon w minus z dw. So either we write f of w or w minus z0, w minus z0, not a w minus z, w minus z0. So w minus z0 dw. So what is the residue? So if fz have isolated singular point at z equals z0, then this one is expressed as a Lorentz expansion. So in a Lorentz expansion, in Lorentz series, the coefficient of first term, the coefficient of first term of principal part principal part, that is B1, is residue of fz at z equal z0. At z equal z0. So in the Lorentz series, the coefficient of the first term of the principal part, that is B1, is residue of fz at z equal 0. So mathematically, how we write this one? So B1 is a what? B1 is a residue of fz at z equal z0. If z0 is a what? Z0 is a isolated singular points. So this one is a residue. This one is a residue. Now, if we write the value of a B1, what is the value of a B1? Either we write fw, w minus z0, dw, or we write fz. So what is the value of a B1? So B1 become what? 1 upon 2 pi I integrate over what? Integrate over C fz here w minus z0 to power what? Minus n plus 1. Sorry, minus n plus 1. So if n equal 1, then what is the denominator? Denominator become what? Minus n plus 1 minus 1 plus 1, then this become what? 0. So this one is a Bn. Bn means 1 upon 2 pi I integrate over C fw, w minus z0 minus n plus 1 dw. C is a closed contour inside the anomalous region. C is a what? C is a closed contour. Closed contour. Inside mod of z minus z0 is less than r and greater than c. So here, if n equal 1, then denominator become 1. This become fz dz. Here, however, we write fw dw. So you may write also either variable is it w or z. This one doesn't matter. So fz dz equal what? Residue of fz at z equal z0. Residue of fz at z equal z0. So why this one is important? So if we try to find out the integration of this one, you may also write this one in this form. Integrate over C fz dz equal 2 pi I into residue of fz at z equal z0. So if we try to find out the integration, means integrate over C, where C is a contour where in the region where the function is analytic, fz is analytic, equal what? 2 pi I. We find the residue of fz, this fz at z equals z0, and multiplied by 2 pi I, then be able to find out the integration. That's why this one is a very important result, means to find out the value of integration. Now, since residue of isolated singular points, so residue of isolated singular point means how we find the B1 in case of isolated singular points. So how many types of isolated singular points? There are 3 types of isolated singular points: removable singular points, pole, and essential singular points. So now we try to explain a residue if isolated singular point is a removable singular points, residue if isolated singular point will be the pole of order 1 or pole of order m, residue of essential isolated singular point, then how we find the residue. So one by one we discuss about how we find the residues. So one by one we discuss about this one. So once we erase out this one, then one residue of removable isolated singular point. Singular point. Isolated singular points. So as we know that in case of a removable singularity, there is no any term in a principal part of a Lorentz series expansion of a fz. Suppose fz be any function, fz where a function which have a removable singularity, fz have removable singularity at z equal z0. Then if we write Lorentz expansion of this one, how many number of a term in a principal part? There is a 0 term. Means fz can be written as what? Only there is a Taylor part. N equals 0 to infinite an z minus z0 to power n. There is no any principal part. 0. There is no any principal part. So if there is no any principal part, then how we find a v1? We are unable to find out a v1 because what is the residue? Residue is a first term. Residue is a what? Residue is a coefficient of a first term of the principal part. So if there is no any term, then what is the value of a v1? v1 equals 0. If v1 equals 0, so what we define here, residue of a fz at z equal z0. If z0 is what? Removable singularity equal to what? Equal to 0. So in case of a removable singularity, what is the residue? Residue of a fz at z equals z0 is a 0. Now, if we define the removable residue of a pole of order 1, residue of a pole, isolated pole of order 1, pole is a what? Isolated singular points. Residue of a pole of order 1, pole of order 1. Order 1 is a residue of a fz at z equal to 0 and z equal to 0 have a pole of order 1. Pole of order 1. So, as we know that pole is what? Isolated singular points. Isolated singular points, then we able to write a Lorentz expansion fz equal summation n equals 0 to infinite an z minus z0 to power n plus how many number of terms in a principal part? There is a one term and that term is a what? v1 divided by z minus z0. So now what is our aim? Our aim is to find out the value of a b1. So how we find the value of a b1? So to make this one more simple, we write here a0 plus a1 z minus z0 plus a2 z minus z0 whole square up to infinite number of a term, and last one is a v1 divided by z minus z0. So in a left hand side and right hand side it will be multiplied by what? Z minus z0. Z minus z0. Then this becomes fz and here this becomes a0 z minus z0 plus a1 z minus z0 whole square plus a2 z minus z0 whole cube, and what is the last term? Only v1. And what is our aim? Our aim is to find out the value of a v1. So how we find the value of a v1? If we take the limit both sides, first we multiplied by the z minus z0, now we take the limit. Limit z tends to z0, z tends to z0 of a what? Z minus z0 of a fz. Then what will happen in the right hand side? This term becomes 0, this term becomes 0, this term becomes 0. What is the meaning of this one? Means a Taylor part becomes 0. Only the remaining part is a what? b1. So this one is a what? We are able to find out the value of a b1. b1 is a what? b1 is a nothing else. Residue of a fz at z equal 0. So what is the residue? Residue become residue of a fz at z equal z0 equal limit z tends to z0 z minus z0 to power 1, and this one is fz. This one is what? Residue of a fz if z equals z0 have a isolated singular point and that isolated singular point is a pole of order 1. Now what will happen if there is a pole of order m? If there is a pole of order m, then what will happen and how we find the isolated singular, or how we find the residue, not isolated basically, how we find the residue. So means a isolated singular point, and under the category of a isolated singular point, here a pole of order m. Pole of order m. If there is a pole of order m, then how many number of a term in a principal part? There is a m term. So here we write fz equal summation n equals 0 to infinite an z minus z0 to power n plus how many number of a term in a principal part? M term, z minus z0 plus v2 z minus z0 whole square up to vm z minus z0 to power n. So what is our aim? Our aim is to find out the value of a v1. So we multiply z minus z0 to power m on both sides, then this become what? Summation n equal to 0. So here we write z minus z0 to power m, 0 to power m, summation n equals 0 to infinite an z minus z0 to power n plus what is the value of b1? If we multiply it by the z minus z0 to power m, then this become what? b1 z minus z0 to power m minus 1 plus b2 z minus z0 to power m minus 2. Similarly, what is the bm? bm, this one cancel out z minus z0 to power m and z minus z0 to power m. So this become what? bm. So this become a bm. If this become a bm, now what is our aim? Our aim is to find out the value of a b1. So how we find this one? So if we differentiate the left hand side and right hand side, this one is a constant term. If we differentiate one time, then this term becomes 0 and previous term from this term become a constant. If we differentiate 2 times, then 2 term becomes 0. If we differentiate m minus 1 time, then this term become constant and this become. So now we differentiate the left hand side and right hand side how many times? M minus 1 time. dz m minus 1 z minus z0 to power m fz, and this become what? This become m minus 1 m minus 2 m minus 2 up to what? And z minus z0, z minus z0, because here and with this one there is a Taylor part an z minus z0 to power n plus what? Factorial m minus 1 into b1. Because if we differentiate this one time, then m minus 1 into z minus z0 to power m minus 2, then m minus 1 into m minus 2, m minus 1 time m minus 1 into m minus 2 into m minus 3 up to 1, so this become factorial. So if we take a limit, because what is our aim? Our aim is to find out the value of b1. If we take a limit z tends to z0, then this term becomes 0. So limit z tends to z0, dm minus 1 upon dz m minus 1 z minus z0 to power m fz, this become what? This become factorial m minus 1 b1. So what is the value for b1? b1 become 1 upon factorial m minus 1 limit z tends to z0 d m minus 1 upon dz m minus 1 inside z minus z0 to power m fz. This one is what? This one is the residue. So if we write here residue of fz at z equal z0. This one is a. This one is a. If at z equal z0 is a what? Pole of order m. So this one is a what? This one is a residue in case of a pole of order m. And last one is a, if removable singular points means not removable, what I am saying here, isolated singular point is the what? Essential singular points. So in case of a essential singular point, how we find the residue? So there is no any procedure to find out such procedure like pole of order 1, pole of order 2 or pole of order m. In case of a essential singular point, how we find the singularity? essential singular point. Residue at essential singular point. Residue at essential singular point. At essential singular point. Essential isolated singular point. If we write here, isolated singular point. Essential isolated singular points. If we write in this way, more precisely, residue at essential singular point. Residue at essential isolated singular point. Isolated singular point. So how we find this one? So if Fz have an essential singular point, Fz have essential singular point, singularity at z equals z0. Then there is a one and only one way. Write the Lorentz-Ridge expansion of this one. And in a Lorentz-Ridge expansion, principal parts have an infinite number of terms. Means summation n equals 0 to infinite an z minus z0 to power n plus how many number of a term in a principal part? There is a v1 z minus z0 plus v2 z minus z0 whole square up to how many number of terms? Infinite number of terms. So we find the Lorentz-Ridge expansion of fz about z equals z0. Then coefficient of a first term of the principal part. What is the coefficient? The value of b1 is nothing else residue of a fz at z equals z0. And sometime you may also solve by replacing what? Z minus z0 by t. Z minus z0 by t, then this become what? This become a n t to power n, like this one. Means sometime you may also replace this one, z minus z0 by what? T. Then fz become what? fz0 plus t. fz0 plus t. fz0 plus t become what? This one is the summation n equals 0 to infinite an t to power n plus b1 by t plus b2 by t square, and how many number of a term? Infinite number of terms. So here the coefficient of a 1 by t, coefficient of 1 by t represent what? Residue of a fz at z equal z0. So this one is a what? This one is nothing else, b. So in this way we find the residue isolated at isolated singular point. If there is a removable singularity, the residue becomes 0. If there is a pool of order 1, limit z tends to z0, z minus z0, fz represent what? Residue at z equals z0, pool of order 1. If there is a pool of order m, then limit z 1 upon factorial m minus 1, limit z tends to z0, m minus 1 a derivative of a z minus z0 to power m, fz. This one represent what? Residue of fz at z equal to 0, z equals z0 if there is a pool of order m. In case of a essential isolated singular point, we able to find out only with the help of a Lorentz-Ridge expansion. In a Lorentz-Ridge expansion, the coefficient of a first term in a principal part is a what? Is a residue of fz at z equal to z0. At z0, there is a essential singular point. You may also write z minus z0 equal t. Then the coefficient of a 1 by t represent what? Represent the residue of fz at z equal to z0 if z0 have a essential singular point. So this one is all about this lecture. In the next lecture, we discuss about a residue at infinite. Residue at infinite and what is the relation between residue at infinite and all other sum of a residue of all other points. And also we discuss about a Cauchy residue theorem and try to solve some numerical example based on these results. Means we try to find out the residue and we try to find out the value of integration with the help of a residue theorem, and also we try to solve some numerical example to find out a residue at z equal infinity. Thank you for watching my video.